Today we're going to talk about rotating around a vertical axis. For example, suppose we want to rotate the area between y equals x squared, x equals 1, and y equals 0 around the y-axis and find the volume of the resulting solid of rotation. So what have we got? We sketch this. Here's the curve y equals x squared. Here's the line x equals 1, y equals 0 is the x-axis. So we're talking about this area in here rotated around the y-axis. It's going to cut over like this, more or less, and in a different color, we'll have some sort of weird thing like this. There's sort of this dish inside. It could be a cup that was so sharp it would cut your mouth on it and be really heavy because of this clunky thing and might leak out the bottom. I don't know. I sort of imagine this as maybe a car part. The trick to doing this is, well, one trick to doing this is to switch all the x's and y's. All the x's and y's. That is to say, rotate the area between x equals y squared, y equals 1, and x equals 0 around the x-axis. You see? Because now it's a vertical and now it's a horizontal axis, as we're familiar with. So what have we got? X equals y squared is the same thing as y is the square root of x. And so now we are rotating. What have we got? We've got y equals the square root of x. And y equals 1 is this line. Y equals 1. And x equals 0 is the y-axis, so we're rotating this area around the x-axis, and we get something which hopefully you recognize as that exact same object just on its side, and its volume will be the same. And what do we do? Well, we're going to have to look at this as two different curves. One of them is the curve, well, it's right there, y equals 1 and y equals square root of x. And if we slice it into slices, the volume is going to be the integral from, let's see, what's this point? This is the line 1. So from 0 to 1 of pi 1 squared minus pi square root of x squared dx. That's not so bad. This is pi integral from 0 to 1 of 1 minus x dx. Well, holy cow, that's not so bad. We could even do this, couldn't we? Pi times x minus x squared over 2 from 0 to 1. Man, I love plugging 0 into things because it doesn't do anything. We've got 1 minus a half. Pi over 2. Yeah. Pi over 2 is the volume of that clunky, yeah, I guess you could use it for a vase, maybe? I don't know. It'd be pretty heavy, so it would be the kind of vase that wouldn't flop over. Although, it's just maybe for bushes or something. Anyway, the problem with this method, in this method, anytime someone has you do things in terms of y, and you don't like it, and you think, oh, for the days when I worked with x's, this trick is a lovely one. Just replace all the x's with y's and all the y's with x's. You're just changing variables. It doesn't change the question, but it could make things a lot more familiar. It's like if someone gives you a problem in t's and it makes you uneasy, just turn them into x's. There's no difference. The problem lies when you have something like, let me just draw a picture. If you had a function like this, y equals f of x, and you wanted to rotate, let's say, from A to B, this area around the y-axis, then I suppose you can see what it's going to look like. Something like this. It's going to be, I always think of these things as sort of car parts. I'm really technically inept, and so there's all sorts of weird lumps of metal that fall off my car, and I keep it and give it to a mechanic, but they look like this. You can see that there's sort of a hollow space through the middle. There's just, I don't know, some sort of little edge there. Anyway, the problem with this is that this particular function, if you rotate it on its side, is no longer, if you replace all the x's and y's, x equals f of y, you're going to have a heck of a time solving for y because it's not a one-to-one function. This is not invertible. So you're kind of stuck. So what we have is another method, and the method is called the method of the slicing before was slicing things into disks. Now we're going to slice things into shells. What we're going to do is we're going to go, again, we're going to use all these different x values, little slices from A to B, and the first slice like this, we are going to rotate each slice around. So this slice is going to form basically like a cylinder, like that. And then the second slice is going to form, this slice right here, is going to form a slightly larger cylinder. If you can see that. Maybe not quite as tall, but kind of bigger and bigger. Wait, I heard someone say that a roll of toilet paper could be viewed as a whole lot of cylinders. Every time that the toilet paper goes around once, it sort of forms this internal cylinder. Now, the outer ones are bigger, which is why when you use toilet paper, for the first, I don't want to get into too much detail, but it doesn't seem to disappear as much. But near the end, you can have a decent amount of toilet paper, and it can disappear very, very quickly because it's going around a shorter distance. Maybe you could think of it this way. I'm going to try to bring some like kids stacking cups, if I remember, into class. But if you had like a little cylinder like this, and you put around it a slightly larger cylinder, but slightly shorter, and then another one that was slightly wider and slightly shorter, and another one that was slightly wider and slightly shorter, and you kept doing that, more and more and more, you could get a sort of solid of rotation that maybe looked like this. Can you see that? I don't know what this object would be. It's kind of hollow in the middle because we didn't start all the way down. But basically, rather than taking a whole lot of slices, what was it? How do I draw these? Previously we took a whole bunch of discs and we added them all up and stacked them together. Maybe the discs got smaller again, and the discs got smaller again, and the end result was something like this. Which would be a solid of rotation sliced into discs, where each particular slice was like a disc. Now we're kind of chopping things into cylinders, where each particular slice is a cylinder. Hopefully you can see that. I feel like this video has gone on long enough. I'm going to pause, and the next one will give the formula.